Today I'm going to show you how to use the group by functions with Pandas. And I'm going to use a data set that I created in Microsoft Excel. And it should be useful. Okay, I'm going to use Jupyter Notebooks. And here we go, starting through Anaconda. Okay. Desktop and group by tutorial. Okay. Well, see, I already have the test purchase data.csv in the same folder, and I'm going to start a Python 3 kernel. Okay. As with anything else with Pandas, you first import Pandas as PD. Okay. Now, then you read in the data frame. Read underscore CSV. And the name of the file in this case is test underscore purchase underscore data dot CSV. Okay. Let's run this. Okay, no errors or anything. Okay, let's do shape, just to see how big a file it is. Okay, it's 8 rows and 6 columns. Okay. It's also advisable to print out the column names. Okay. See, here is a list of the column names in this data file that I created. Okay. Now, if you print out the entire thing, the entire data frame, by just clicking DF and then hitting return and pressing enter, in Jupyter Notebook at least, it prints out this very neat table. It does it in HTML format. That's something you should know for later, but very nicely formatted table. Okay, notice how the usernames repeat, and the ages repeat with them, which is to be expected because they don't suddenly grow older. And the purchase items can also repeat, but different people can purchase the same thing. Also, the prices repeat. Okay. Let's take a look at what an aggregation function does by itself without a group by. Best way to do this is to try something that's a little bit unusual. Let's make a data frame object and do df.agg and then okay. sum min. Okay. And then df2 and hit run. Okay, this does exactly what I expected it would do, which is it sums up all of the columns and puts them into a single row. And then it takes the minimum of each column and puts that into a single row. This is pretty useless, but it just goes to show you that you need to be careful of what data you put together with an aggregate function or a group by function. You will notice that the summation function just concatenates all of the usernames from the column. The summation function also concatenates all of the genders from the column, and it adds all the ages and adds up the purchase IDs, which doesn't make sense at all either, and it concatenates all of the purchase items. It does, however, add the prices correctly. Okay. Now the min function, you will notice, does come out with a single value that looks correct, but if you look back, Jacob 88, Jacob is not female. This is not a real person, okay? That's another thing you have to take into consideration when you do aggregate functions. You have to make sure that they are real rows, real records that result. Obviously, summing up usernames is not something that you can do, or summing up genders. Okay. Now, let's try our first group by command. Set grouped underscore df equal to the data frame that we already read in, dot group by, and then we put in the column name gender. Okay. And we run this. Okay, this is interesting. Comes out giving us a pointer to a data frame group by object. Okay, why does it do this? Well, despite, why doesn't it just give us the gender column? We don't have, if you just gave you the gender column, that's pretty useless. And you don't ask for any other columns. So it doesn't know how to refer to it or perform that group by function. Okay. Let's try something else. Grouped. Let's do a different data frame object, df1 equals df dot group by. This time, put in 2 column names, gender and age. Then sum them up. Don't even ask if this will be useful. You will see in the results, probably not. Okay. Now, it looks good, but purchase IDs are added together unnecessarily. The ages, fortunately, are not added together because that is one of the things that's grouped by. Otherwise, it would be added together. Okay. Now let's do something that actually is what we want it to do. Oh, well, in this case, if you ever wanted to, because it's grouping by 2 columns, if you ever wanted to refer to one of the column names in the future, it is best, one of those, gender or age in the future, it is best to do reset index. Otherwise, it's hard to make formulas that work. So df1 dot reset underscore index. Okay. Okay. Now, once you reset the index, it actually puts its own index in there, and it's 0, 1, 2, 3. Okay. Now let's do something that's actually useful. It's called grouped df2 equal to df dot group by, and do again gender this time, but then let's do an aggregation function, but only on a particular column. Now, the best way to do this, I think at least, is to do an aggregation function on a dictionary. The dictionary, the first key in the dictionary, in this case, is the column name that we want to perform a aggregate function on, and that is user name. Okay, and again, it's in single quotes. You can do double quotes or single quotes. It doesn't matter. I like single quotes. I think it looks cleaner. Okay. Now, the function, and this is the part that's a little bit unusual. The function itself is in quotes. Why is that? That's because the function becomes the column name in the group by function. And you may not want that. But let's see what grouped df2 looks like now. Whoops. Oh. Sorry, .agg. What was I trying to do? It's .agg. Of course I was trying to do an aggregation function. Okay. Silly. Okay. There we go. Okay. Counts the number of males and the number of females. Okay. Now, but then it puts them under in unique. You may not want to call a column in unique. And you also run into issues when you try to make formulas with column names that happen to be aggregate functions like sum or min or max or what have you. The best way to deal with this, well, we'll get into that later. That's to rename the column names. But before that, let me show you how you can do aggregate functions on multiple columns and do multiple functions on multiple columns. Okay, let's do grouped df3 equals df dot group by, again by gender, and again we're doing aggregation function, and again we're doing a dictionary within the aggregation function to point to the columns, and you start out with, again, user underscore name and colon and then square brackets and single quote in unique. But then you could add other columns and other functions to that aggregate function. Okay, for example, purchase underscore ID colon, and then again, it seems weird to me to put the function name in brackets and quotes, but it actually becomes a column name. Okay. And one other thing that you can do is apply multiple functions to the same column. And let's take price colon and min, comma, max. Again, they have to be in square brackets, and the list has, each member of the list has to be in, well, quotes. Max, mean, sum. Okay. And end. Okay, you end the square brackets, you end the dictionary, and you end the parentheses for the aggregation function. Okay, and then df3 and run that. Okay. Again, you get the column names in unique, count, min, max, mean, and sum. This may not be what you want for column names, but at least this time it comes out with things that make sense. Okay. Now, I will show you how to rename the columns. Grouped underscore df3 dot columns equals, and then make a list of the column names in quotes, either single or double quotes. Okay, we can call the first column gender count. Okay, we don't need to, first of all, we don't need to do the gender as a list in the column list, because that's inherent in the group by object that you created previously. Okay, so the next one is the number of unique names, number of unique usernames, and that fits. It's actually the gender count in this case. Okay. And then the purchase count. The low price. The high price. Average price. Finally, total by gender. Okay. And then show grouped df3. This time it has the much nicer column names on it. Okay. Now, what if we want to make a function that applies to certain columns? One way we can do that is just setting the grouped df3 and then whatever the column name that we just gave it, say, well, actually, we want to create a new column and set this function equal to a new column. That way, the results are stored in that column series. Okay, and let's call this new column gender underscore percentage. Okay, gender percentage, and it equals okay, and then make sure you use the column names that you just put in there. Gender underscore count. Let's put this in parentheses. You probably don't have to, but just to ensure that the order of operations works properly, I like to put things in parentheses when I'm actually doing math on other functions. And divide the gender count column by the gender count sum. This is, or actually, you could do this several different ways, but okay. Could do this several different ways, but in this case, I'm doing it in a rather strange way, but because I don't have total number of users. Oh, wait, I do have a total number of users, but I haven't saved it to I haven't saved it to a variable. So the best way to do it is to make one total number of users based on the sum of the gender count. Okay. And then multiply that. Okay, well, first of all, put that side in parentheses as well, and then multiply that by 100 to be a percent. Okay. Then df3 and run. Whoops. Right. Okay, put an extra percentage sign on there. Okay. Ends up coming out with the right percentage. There's one female, 3 males. Females make up 25%, males make up 75%. Okay, that actually works nicely. If you want to see the this code, or you want to see the Jupyter notebook that created it, and you can go to my GitHub page. Also, like this video and subscribe to my YouTube channel.